All right, welcome to part two of the physics-based sliding tutorial. So in the last part, we got it set up, or we got a lot of the fundamental or foundational stuff set up, and we got sprinting set up as well. So in this one, we're going to set up crouching and probably finish sliding as well. Okay, so let's look at the input action crouch event. So in this one, we kind of want to do a similar stuff to what we did for sprinting. So as you can probably guess, the first thing we want to do is we want to set the crouch key down to true if it is pressed. So we'll set this to true. And then we also want to set the movement state to crouching as long as we are in a valid state to do so. So for that, we want to drag in our handy little switch movement state macro and hook it up. And so we only want to crouch if we are currently walking. Otherwise, we don't want to crouch, because if we're sprinting, we want to just keep sprinting basically. Or sorry, if we're sprinting, we want to actually do a slide. If we're walking, we want to crouch. And if we're crouching or sliding, we basically just want to ignore it because we're already in that state. So like I said, if we are walking, then we want to go to crouched. So we'll drag in our set movement state and we will set it to crouched. And if we are sprinting, then we want to set it to sliding. Because again, if we press the crouch key while we are sprinting, that is going to activate our slide. So we want to select sliding. And then when it is released, all we want to do is we want to set crouched key to false. And then the system that we have in place here later will handle uncrouching us, because we can't just necessarily uncrouch right away because we might be underneath something, or we might be in the middle of a slide, for example. So we just want to set this to false, and that's really all we want to do for right now. All right, so we got our sprint, we got our slide. The next thing we need to do is actually add in the logic to make our character physically do those things. And that's what these are for. So we have this begin crouch and end crouch, and we're going to be hooking this up to a timeline. So if you right click and say add timeline, it will add a new timeline, and we will call this the crouch timeline. And begin, we want to hook it up to play, and then end, we want to hook it up to reverse. So let's go inside of here, and we want to make a few little changes. So we want to add a float graph for the half height of the capsule, because actually what we're going to do when you crouch is we're going to shrink the capsule, and we are also going to move the camera down. So let's deal with the first one first, which is shrinking the capsule. So let's add a float track, and we will call this half height. And so this is referring to the capsule's half height. And so inside of here, we want it to start we want to change the length of this to be something pretty short, like 0.3. So this is basically how long it's going to take for us to be fully standing to fully crouching. So if you want to make this time shorter or longer, then you would adjust it here. And then you also need to adjust where you put these nodes. So the first node we're going to put at, just right click and say add key and put it anywhere you want, and then click on it and set it to 0 for time and a value of 1. And then right click again somewhere to the right, and we want to add one more, and we want to set it to a value of 0.3 on the time and a value of 0 for value. And if you press just F on your keyboard, it will focus the two things that you added and kind of format it a little bit easier so you can see what's going on. So basically all that's happening is we have a key that goes from 0.1 to 0.30. And so this is representing the it's a value from 1 to 0, which represents how much we are standing. So when it's 1, we are standing, and when it's 0, we'll be crouching. And then we want to do something similar for the camera. So we want to actually move the camera down. So we're going to add another float curve. So we'll add a float curve again, and we'll call this one the camera offset Z. And then we want to add, actually, I'm just looking at this right now. We don't actually need two of these. I have two of these in my other project, but I just realized they're exactly the same because I went back and changed it later. So never mind. Actually, we'll do it live. Let's just delete this guy. How do I delete this? Right click, delete, yeah. So actually that's all we need. We just need this one event graph. And then I don't think we need to check anything else. No, we don't. Okay, so back here in our movement graph now, where we are using this timeline, what we want to do is we want to adjust the capsule half height and the camera. So we will say capsule half height. So we'll drag in our capsule and we will say set capsule half height. And so our half height is going to be, so if you think about it, when we're standing, we want it to be set to our standing capsule half height. So let's just drag that in. And then when we are fully crouched, we want to set it to, well, something else, but something much smaller than this value. So in order to do that, we wanted to do it based on this half height. And remember, this goes from 0 and 1. So we want to convert this value, which goes from 0 to 1, into a value that goes from our standing capsule half height to our crouching capsule half height. So there's a handy little node for that, which is called map range clamp. And what it will do is it will take in a value from 0 to 1, which is what this guy is, and it will convert range A to range B. So range A is 0 to 1, and range B is going to be, so whatever we put here is basically going to be the half height of our capsule when we're crouched. And you can make a variable for this if you want, but I'm just not going to do it. I'm going to just set this to 35, and then our outrange is going to be our standing capsule half height. Because if you look at the capsule component, and you look at the half height that it starts with 96. So that's our standing capsule half height. So we're setting it all the way down to 35, which is pretty short when we crouch. And that is what we're going to hook up to our set capsule half height. And then also, like I said, we want to move the camera down. So let me just move this over. And then I'm going to double click to create a reroute node. And then drag this around because we're going to need this value over here. So let's just leave it like that for right now. So we're going to drag in our first person camera from the left and say set relative location, like so. And so we only want to change the Z value because we only want to move the camera down. So we want to keep the X and the Y the same. So I'm going to go ahead and split this. And then I'm going to drag off my first person camera again and say get relative location. And I'm going to split this and I'm going to hook up the X and the Y so that way it stays the same. And so the Z is going to come from our timeline. So our Z, again, we're going to use this mapped range clamp. So I'm going to copy and paste this. And so this is ultimately going to go into our Z. So again, we want to take this value. So we will drag this guy over into our value. Oh, this is so ugly. Well, whatever. I guess you can clean it up on yours, but we want to just take that value and drag it into value. And so again, our in range is 0 to 1, except this time our out range is going to be for our camera. So we want to use our standing camera Z offset for our out range B. And our out range A can be, again, whatever you want. You can kind of play around with it. The value that I used in my tutorial is 25. Because again, if you look at the viewport here, the value that we're changing is this guy right here. So this 65, we're changing it down to 25. And then the camera is also going to move down a little bit when the capsule shrinks, but it's not quite enough. So that's why we're also moving the camera. So, let's just leave this at 65. So that's basically what we're changing. Okay, let's go back to our, let's go back to our movement graph. And so now this should change the, or it should make us appear like we are crouching. So let's go ahead and run this and test it out real quick. So if we press C, or if we hold down C rather, it crouches. And then if we release C, oh, nothing works. Why did it not work? Let's see. Let me add a little breakpoint here. You don't have to do this. Clearly I missed something. So let me see what's going on. Okay, so when I let go of C, nothing worked. Oh, wait. I know why. It's because we're never calling in crouch from anywhere. So the way the in crouching works, I forgot about this, is inside of our event tick. So the reason we need to add this logic to our event tick is because, again, when we uncrouch, we can't just automatically, when we release the C key or the crouch key, we can't just automatically assume that we can uncrouch and go ahead and uncrouch, because we could be underneath something, or we could be in a bad state. Like we could be in the middle of a slide or something where we can't uncrouch. So we can't just automatically uncrouch. Basically what we have to do is we have to add a tick here that while we are crouched, it checks if we can uncrouch, and if so, then it actually uncrouches us. So the first thing we want to do is we want to add in our handy little switch movement state. So that way this tick only actually really does stuff if we are crouched, because we don't need to waste cycles if we're not actually crouched. So if we are crouched, then we want to drag in the can stand, and we want to do a branch. And so look that up. So it's saying if we are currently crouched, and we can't stand, then we can just actually go ahead and call resolve movement state. And resolve movement state, if you remember, it will figure out what movement state we should be in, and it will put us into that movement state. Okay, so now if we go ahead and we run this and we press C, and so I hold down C and I release C, it stands us back up. And if I just press it, tap it a bunch like this, it just crouches us. And so things seem to be working pretty well. And so if you try to sprint and crouch, it's probably going to like just break. Yeah, so it's basically kind of stuck now because we're actually in the sliding state, but we haven't written the sliding state yet. So we just kind of get stuck here. But at this point, you should be able to crouch and uncrouch, and it should look nice and smooth like so. And it should actually be moving your capsule down too. I guess we can just make something here to test it real quick. I'm just going to Alt drag this guy over, and then Alt drag another one to copy it, just so we have something to test here. So you can see I can't walk under this, but if I crouch, then I can walk under it. And if I'm under it and I let go of crouch, you can see it doesn't actually uncrouch me because there's not enough room for me to stand up. But if I go out of it, then it finally uncrouches me. So yours should be working exactly like this. If it doesn't, then definitely go back and try to figure out what you messed up before you continue on. Okay, so now that we have the crouching working and some of the uncrouching logic working, let's go ahead and work on the slide. So finally, the meat of what we really want to get out of here. So let's go to our begin slide. So inside of here, the first thing we want to do is we want to start the camera tilt. Let me move this down a little bit so I have some room. We might need a little bit more room. Okay. So again, the first thing we want to do is we want to start the camera tilt, which is down here. And we'll actually do this last, but we will at least just call these functions for right now, so that way they're hooked up. So we can say begin camera tilt, and then we can also say end camera tilt, like so. And then we want to start our timeline. So we'll say add timeline. And this will be our slide timeline. And then we want to hook this up to play. And we want to hook end up to stop. Make sure you go into stop and not reverse. So this timeline is just kind of more of a tick, if anything else. It's actually not really going to do anything other than just tick for us. And so we can just open this guy up. And inside of here, we can just change the length to like 1. It doesn't really matter because we're going to set it to looping. So if you set it to looping, it will just continuously loop over and over and over. So it's basically just a tick that only runs when we are sliding. And so we can just compile and save this. And we can just close that guy and come back here to our movement graph. Okay, so inside of here, the first thing we want to do is each tick, we want to add force to our character in the direction that he is sliding in. So to get that, let me think. Get actor, calculate floor influence. Yeah, so we need to write this calculate floor influence function because we're going to be using the current floor that we're on to figure out which way we can slide. So that way, if we're going downhill, we'll know that we should be going faster, or if it's sloped to the right, we'll know that we should be going to the right. So in order to get the current floor, you can actually just grab a lot of people don't know this. I didn't know this for a long time. You can actually just grab the character movement component and you can say get current floor. And so this is a structure of information about the current floor that you're on. So if you right click and you split it, you can see all the information here. So the thing that we care about is this hit result. And the hit result is basically the result of a line trace from where our player is standing into the ground. And so we can then break this and hit this little drop down button. And so this is the result of that line trace. And so what we want to know is we want to know the normal of the floor, the normal vector of the floor. And from that, we want to calculate our floor's influence on our slide. So that's what this function's for. So if we drag in calculate floor influence, again, we want to change this to be pure and const as well. So we can just call it without the execution pens. And we need this to take in the normal. So if we open this guy up, so let's just double click on him. Let's go ahead and fill this out real quick. So this is just going to be some simple math to kind of figure out how the floor should influence our slide. So we'll add an input parameter here. It needs to be of type vector. And this is going to be the floor normal that we're currently standing on. And what we want to do is we want to return a vector of the direction that the floor should be pushing us in, if that makes sense. So for example, I'll just kind of show you real quick. So for this floor that I'm standing on right now, the vector that would return would be going from like right to left and downwards, like towards the ground. So it's basically the direction that the floor is facing. This type of vector or this type of floor would just return to us 0 because this floor would have no impact on which way we are sliding. This one would return a vector that goes down like towards that hole basically. So that's kind of the idea here. So in order to do that, we're going to be using the cross product. And so the first thing we want to check is this floor normal equal to the up vector? Because it's equal to the up vector, that means it's just a flat surface, and then we can just return 0. And so we'll say equal, and we want to check if it is equal to the up vector. So you can just right click and say vector up, and that will return the up vector, which is just 0, 0, 1. And we can do a branch like so. And so if it is the up vector, we're just going to go ahead and return 0, 0, 0 because it has no impact. So we'll add an output parameter, and we'll just call this return value, and then hook this up to true and leave it as 0, 0, 0. But if it's not the up vector, which means the floor has some sort of slope to it, then in order to find the direction that we want to slide in, we need to take the floor normal. So we'll say get floor normal, and we need to cross that. So we'll say cross product. And if you don't know what cross product is, I would highly recommend checking out. I have a video on my channel called, I think it's called Game Math Essentials, but I cover what the cross product does. But in short, it basically returns a vector that's perpendicular to the two vectors that you pass in. And so we're kind of using that to figure out the direction. So we need to cross that with the vector up. And then we need to take that vector and we need to cross it with the floor normal again. So we'll say cross product. And so it should look like this basically. And then we want to take that vector and normalize it. And again, if you don't know what any of this is if you don't know what I'm talking about right now, I highly recommend watching that Game Math Essentials. It covers all of this stuff. Okay, so this is the direction that we want to slide in. So we'll hook, so we'll hook this up and we'll hook this up to the false. So again, just to kind of recap, all we're doing here is we're saying, is the floor flat? If it is, we're just returning zeros for the influence because it's flat. And if it's sloped, then we're calculating using some math the direction that the floor would be pushing us in. Okay, so now we can come back here to our wherever we are, kind of in the middle of nowhere, and we will hook up the normal to the floor normal. And then from there, we want to take this value and multiply it by some amount because we're eventually going to be calling add force. So actually, let's just do that first. So let's drag in the character movement and say add force. And that's going to be hooked up to the update because we want to do this each tick. And then this force value, let me drag this around. So the force value is coming from this thing right here. So we can't really just hook this up like this because the force is actually expected to be a quite high number. So if you say float multiply, we just want to multiply this by some value. Now you can kind of experiment with this number and figure out what number works best for your game. But basically, the higher the number, the more the floor will have an influence on where the character is going, if that makes sense. So we'll say, I think I used 150,000 for the force. That's just the way the force numbers work in Unreal. They're pretty big numbers. So multiply it by 150,000, and that will give us a nice force applied. So from there, we want to do two things. So we want to first, so let's add a sequence node. So again, hold down S and left click to add a sequence. So the first thing we want to do is we want to make sure that we don't get going faster than like our terminal speed, basically. Because if we're sliding down a ramp, like we want to get faster, but we don't want to just like infinitely get faster until we're just moving faster than you could even possibly imagine, right? At some point, you're going to stop getting faster if you're sliding down a hill. So we'll just say that our sprint speed is our max speed that we can get up to if we're sliding down a hill. And again, you can change this to work for your game differently if you want. It's pretty simple, but I'll just show you how to set it up. So basically, we want to calculate our speed. So to get our speed, we can just get our velocity. So get velocity, and then we can get the length of that. So vector length. And so the length of your velocity is your speed. And so we want to check if that is greater than our sprint speed. So again, if you want it to be like faster or slower than your sprint speed, you can basically just pass in a different value here. But this is essentially your terminal velocity when you are sliding down the hill. And so we'll say branch. So this is just checking, have we reached or have we passed that speed? And if we have passed that speed, then we want to clamp our speed to that speed. So in order to do that, we need to get our velocity and we need to normalize the vector so that we get the direction of it. And then we need to multiply it by whatever that speed is. So we'll say float multiply. And again, we're using the sprint speed. If you're using a different speed, you'd pass it in here. So just make sure these two are the same. And then we will set our velocity to that. So if we say character movement, set velocity, like so. So this will ensure that we don't get going like way too fast, which obviously nobody wants. Okay, and then let me just move this over. So that's the first step. And then the second step is like, so if we're not, or sorry, the second step is that if we get too slow, then we want to actually stop the slide. So this is making sure that we don't get going too fast. And then this is making sure that we don't get going too slow. And so to check if we're going too slow, again, we can get our speed by getting the vector length of our velocity. And except this time we want to check if it's less than a number. So we'll say float less. And then we want to check if it's less than, so I'm just going to use the crouch speed. So I'll say if you get moving slower than the crouch speed while you're sliding, then just go ahead and abort the slide. And so that's how the slide actually finishes in most cases. Again, if you want to use a different speed, just hook up a different speed here and it will use that one instead. And so if we do get going too slow, then we just want to call resolve movement and it will pop us out of this slide. All right, so let me make sure I got everything. I think we did, except we did skip over something inside of on movement state changed that had to do with sliding. So we need to go back and fill it out before this will actually work. So let's go into on movement state changed real quick and finish writing this. So there's something important we need to do when we start sliding, which that is basically we need to change the friction of our character so that he slides more easily. And we need to reduce the braking deceleration so that he doesn't slow down as fast when he's like sliding against the floor, basically. So let me think the best way. Okay, so yeah, so let's add one more pin here to the sequence. We're actually going to do the then 2 first, just because I think it makes a little bit more sense if I explain it that way. So we want to drag in our switch movement state and hook it up to the then 2. We'll come back and do the then 1 in a second. So we are looking at our new movement state. And so we want to say if our new movement state is sliding, then we need to basically set those values. So the first thing we want to do is we want to set our velocity to be our equal to our sprint speed. So that way, if we just quickly do a slide, we'll immediately be set. Our speed will immediately be set to our sprint speed. So that way, our slide is always a consistent speed. And so we want to get our actor's forward vector. So we'll say get actor forward vector because we need to calculate our new velocity. And we obviously want to slide in the direction that we are facing. And we want to multiply that by our sprint speed. And so that will give us our slide velocity. And so we want to set our velocity to that. So we'll say character movement, set velocity to this guy. Okay, so now our velocity is set up correctly for our slide. And then, like I said before, we need to change our friction so that we can actually slide. So we'll drag off of our character movement again, and we'll say set ground friction. And so we want to set the ground friction to 0. So if you look at the ground friction and the character movement, just look at it real quick. You can see by default it's set to 8. So the higher number this is, the more friction will be applied. But it's not the only thing that slows down your character. There's also this thing called braking deceleration, and there's a bunch of them. But the one we obviously care about is the one for when you're walking or the one when you're on the ground. And currently it's set to 2048. So friction and braking deceleration are the two values that kind of affect how fast your character slows down. And so those are the two we want to adjust. So we'll say set braking deceleration, and make sure you get the walking one. And then we will set this one. You don't want to set this one to 0, otherwise you'll never stop. We just want to lower this one. The number I started using was 1,000, and you can play around with both of these values to see what they do. I recommend just like finishing the tutorial first, but once you have the tutorial finished, feel free to play around with these values and adjust them to make your slide like more or less slidey, right? But these are the numbers I came up with, and they worked pretty well. And so that is our slide. And so now that we have that, we basically want to undo this, like undo these changes whenever we finish sliding, which is why I skipped the then one, because that's what that does. So for this one, we actually want to look at our previous movement state, which is this guy. So if we right click and say get previous movement state, we can do a switch, and we'll hook that up to the then one. So this is saying like what was our movement state previously. And so we want to say if our movement state was previously sliding, so like we're no longer sliding, then we want to make sure that we set our ground friction and our braking deceleration back to default. So I'm just going to copy these guys and hook this up to sliding. It's up. So the braking friction, we want to set it back to 8 or whatever you have it set to by default. And we want to set this one back to 2048 or whatever it is set to by default. And then after that, we also want to call our end slide, so it actually finishes the slide. So there it is, end slide. Okay. So I believe that's everything we need. So let's go ahead and give this a try, and hopefully it works. So if I press C, it just crouches me, but if I shift and press C, it does a slide, and then it finishes sliding. Let me just test this a little bit, and definitely test it on your end as well to make sure there is no weird edge cases going on. Because the last thing I want to do is end the tutorial. Well, we still need to do the camera tilt, so I'm not ending the tutorial yet, but I just want to make sure this is working correctly before I continue. Because it's kind of easy to accidentally mess something up. Oh, okay. So if I'm under something and I try to sprint, it's currently messing up. So we'll have to look at that before we finish. Let's do the camera tilt, and then we'll go and address that. Okay, so the camera tilt's actually pretty straightforward. So let's go back to our event graph here. And then, oh, sorry, not the event graph, our movement graph. And let's fill out our begin camera tilt. Okay, so we want to add another timeline. So we'll say add timeline and hook this up to the play. And we want to hook this up to the reverse. And we will call this timeline the camera tilt. I can't type camera tilt timeline. And so inside of here, we want to add another float curve. So hit the little float curve button. We want to change the time to be 0.3 because that is the time that it takes us to crouch. So you probably want this to match. And then we want to add two values. So first one, just right click and say add key. And we will set this to 0 and 0. So at time 0, the camera is rotated by 0. And then add another key and set the time to 0.3, and then set the value to, I think I used -10. Let me double check. Yeah, -10. And then I'm just going to press F to get it all in view. So it goes from 0, 0 to 0.3, -10. So -10 is referring to how much the camera should be rotated. And then if you highlight all of these and then right click on one of them and say auto, it will give it a nice smooth curve to it. And so it's basically saying over the course of 0.3 seconds, change the rotation of the camera from 0 to -10. And of course, you can change this -10 to be whatever value you want for the rotation, but that's just the one that I chose to use. And so back here in our movement graph, we want to set the control rotation because that's actually how you rotate the camera. So we'll say set control rotation. Oh, we need to get the controller. So we'll say get controller. And can I do it from here? Set control. Yes, I can. Okay, so set control rotation. And we want to hook that up to the update. And then we want to split this guy because we only want to change the roll of the camera. So we will hook this up to the roll. Oh, we should probably rename this. Let's go inside of here. Let's just rename this F2 and we'll call it camera roll, just so it has a better name to it. And go back to movement graph. So that's our camera's roll. But for the pitch and the yaw, we want to keep it exactly the same. So kind of like we did before, we're going to drag off this and say get control rotation, and then split this, and we'll pass in the pitch and the yaw so it stays the same. All right, so now if we run this and we do a slide, you can see the camera tilts, and then when we finish sliding, it untilts. So let me go, I'm gonna really quickly look at this bug to figure out how I messed this up, because you shouldn't be able to sprint while you're underneath this, and I'm probably just gonna edit that portion out, so I'll be back in just a second. All right, so I figured out how to fix that. Basically, what all we need to do here is we want to actually change this set movement state inside of the input action sprint. We want to actually just delete this and replace it with the resolve movement state, so that way it takes into account whether or not we can actually sprint. And then another thing we should do real quick that I kind of forgot to do ahead of time, if we go to the event graph, we want to change it so that our input is not, so like if you play right now and you slide, you can see if you press like A and D while you're sliding, you can actually move left and right. And in most games, that's like not the case. So we just want to come up to our event graph and go to our input axis move forward, or wherever you're handling the move forward and the move right. And we want to drag in our handy little macro. And we only want to allow movement if we are walking, sprinting, or crouching. And so that way, if we're sliding, it won't actually work. So I'm just going to copy this and paste and hook that up like so, just to kind of give you an idea. So now if we run this again and we try to slide and move left and right, it doesn't let us. And then the other thing is that you can kind of jump while you're sliding, which again, you probably don't want. So in order to fix that, if we come back over here to our jump, we just want to only allow jumping if we are not sliding. So just like we did before, let me just move this back. Something like this. So we want to say, we want to drag in our little macro. And again, we want to make sure that you are only walking, sprinting, or crouching. And then we also want to make sure that you can currently stand up, because if you're underneath something and you try to jump, we don't want you to be able to jump. So we also want to check if can stand is true. And we'll do a little branch. And we'll hook that up. And we will hook that up. So now if you run this, you should be able to, oops, that did not work. Oh, not can sprint, sorry. Can stand, I meant to say. Okay, so now we run this, we can jump. And if we crouch and we press jump, nothing happens. And if we go underneath something and we try to jump, nothing happens, which is good. And that we should probably not also be able to sprint. So if I try to sprint, nothing happens. So I think that is everything now working. And you can obviously, add a bunch of slopes, because I know we don't actually have any slopes right now. All right, sorry for the hard edit here, but I actually realized something after I totally finished recording the video, that I had forgot to do something. So sorry if there's a kind of weird transition here, but I realized that I didn't take into account like how much the ground was sloped. And so if you were sliding down like a very steep incline, it would slide you just as fast as if you were sliding down like a very not steep incline. So I wanted to just go back and fix that real quick because it only take a second. I just forgot to do it when I was recording the video the first time. So to fix it, all we have to do is open up the first person character real quick. And then we want to go to this calculate floor influence function. And inside of here, we just need to change this to also take into account how steep the floor is. And to do that, we basically want to look at the floor's normal vector compared to the up vector and see how different it is. So if we just copy this floor normal and we do a dot product with the up vector, so I'm just going to copy, I'm just going to copy this up vector and paste it here as well. And then we want to do 1 minus that because we want the opposite of this. So we'll say float subtract, and we'll type a 1 up here, and then we'll hook this up into the bottom. And then we want to say clamp float, just so it stays in between 0 and 1. And then we're actually going to just do the multiplication here for the strength. So I'm going to take this value and say float multiply, and we're going to multiply it by this value times some high number. Because if you remember back here in our movement graph, where we calculate floor influence, we're multiplying it by some high number. So we're actually going to move this into here. So I'm going to delete this and then hook this up, and we're just going to do the multiplication in here just because it's a little bit easier. And we'll just say float multiply and hook this up, and then hook this up to there. And so whatever number you put here, again, is going to determine how slidey it is, or how much influence the floor has on your slide. And we're going to need to go a little bit higher just because we are now adjusting this value, so it's not always going to be the full strength, depending on how much sloped it is. So I'm just going to do 500,000 for this. And so now if we run this, we should see everything working nicely, and I'll kind of demonstrate what I was talking about before. So let me actually, real quick, let me just add in a sloped wall over here. Shrink this guy, make him a little bit wider. So make a really steep wall right here that we can slide down. And then next to it, we will make a not so steep one. So let me just delete this, move this guy over, make it not very steep at all, and move it down. Okay, so if we run this and we go up on this wall and we slide down, you'll see it gives us a pretty big boost, and we slide all the way down the wall. But if we come over here to this one and we kind of do the same type of thing, you see we don't quite get as far. We only get really, to the bottom of the wall. I'll do it again, and then just create this one. You see this one brings us much further away from the wall. And likewise, if we're just doing it at an angle like this, you can see this one slides us pretty much all the way down, whereas this one doesn't slide us very much at all. And so, yeah, I totally forgot to do that in the first part. I didn't realize it was an issue until I finished recording. So sorry for any weird cuts, but we'll go back to the other video now. All right, so that's basically the end of this tutorial. If you guys liked the video, I would appreciate a thumbs up and a like. I also have a Discord channel if you guys want to join there, where it's just basically a game dev Discord channel and you can ask for help. And I also have a Patreon page if you guys want to support me there. It's super helpful and really makes making these tutorials a lot easier. Otherwise, I'll see you guys in the next video.